Let's continue our exploration of the side-side-side condition, and this time let's do it in spherical geometry. So let me find the right one. Here it is. We found that the side-side-side condition worked for Euclidean and hyperbolic geometry. How about spherical? Okay, so basically it works the same as in the other two cases. You start with a circle centered at A of whatever size you want. In this case, it's given here. Let's just make it something easy, 0.7, let's say. And then you go out from there a distance of B, let's say 0.8. Distance from here. That's the distance here. Let's just make it 0.5. And then we go out the distance. That's the distance from B. And the distance from A at the other end has to be, say, 0.8. So we know the vertex has to be on this green circle, and it also has to be on this red circle. Once again, there are two possible values there, and there's one of the triangles that it could be, and there are the angle measurements that come with that. And there was another one, but notice it has the same exact measurements. Once again, this triangle up here is a reflection of this one and vice versa, reflecting over the line AC. And so that's what the triangles look like in hyperbolic or spherical geometry. So again, we can look at this dynamically for some differences there for lengths. Now, once again, we do have the triangle inequality as before. So if the two shorter lengths add up to less than the longest side, then there is no triangle possible, or even if they add up to the same thing, like if this was 0.7 and this was 0.3 and this was just 1, then they would meet right in the middle somewhere. If this is 1.5, then they're not going to meet. But if we could get this longer than that, so it would have to be at least bigger than 1.2, say 1.4, then in fact they do meet twice, and the two triangles you get there are congruent. So there's really only one congruence class. So side is enough to make the triangles congruent. In spherical geometry, you either have a 1 or 0 congruence class possibilities depending on the measurements, whether or not the triangle inequality is satisfied. It's exactly like the other cases we looked at.